Hello everyone, Eric here. So hopefully this is going to be a short video. The goal here today is to show you guys how to set up a very simple project with the bare bones, let's say minimal scripts that you like to use first person. So the focus here is on the programming side, not on graphics, but we'll try to cover the most important aspects that when you're writing code for a competitive first-person shooter, and we're going to demonstrate how these can be done with. The focus is going to be on server-authoritative movements with client-side prediction and reconciliation. Very clean Fusion. Then lag compensated raycasts, how to set up moving targets that are gonna lag compensated for when you're doing raycasts, and how you actually perform the raycasts to be done against the lag compensated, let's say, hitboxes. Third one is gonna be the setup for proper first-person shooter camera, because there is an important timing aspect on when things have to be done and in what you grab as data and where you send it. This is all explained. And last, a basic setup for a player inventory that's server authoritative, but the player can choose things that he's gonna have. So think about your weapons loadout at the beginning of a game like Counter. So without further ado, let's start on the showing the project and explaining what it contains. So this is the basic setup, and I'm not gonna go with all of the details of setting up Fusion because there's another video that demonstrates that well already. So I'll just show the basics here, and the things are actually specific to this game. So we also, like normally it's done on a prototyping, you add this network debug start script to let you select if you're starting a server, a client, or a host, a server together with a client, and this is the quickest way to do prototyping. And it points to a network runner prefab, which is my favorite way of starting a runner, is instantiating it on the fly. And our network runner contains the network runner script, and as I'll demonstrate later, I'm hooking up the input poller for the local player to the local runner, and I'm gonna show the code for these. So besides this guy, we will have only two main Fusion scripts in here. We're gonna have a networked object that's actually used just to spawn the players when they connect. So this is done via an interface for when the player joins. I'm gonna show that, and this is very important because this is very specific to this. This is using our internal hitbox manager that lets you create networked objects that actually are lag compensated, and they can have multiple moving hitboxes inside themselves, and we're going to show how that can be done. Then everything else here is we have some testing geometry for you to move around. So these are standard static colliders, physics colliders for the character controller to move around. And we have a couple of moving targets that actually use the hitbox setup, and I'm gonna show that later when we get to that point. Okay, so this is the basic setup. All the as prefabs here, the only really important prefab here is going to be the player prefab. That's going to be the first we're going to check. And as scripts, it's not a lot of scripts, so just these here, and I think the biggest one is like 70 lines of code. Most of them, I mean, the rest of them are all between 50 or 20, 15 lines of code, so quite small stuff. So this is really just the core, just the basic need. So, okay, so let's start with the order in which things happen here. So when you start the network, either a server or if a client connects to the server, etc., what is important for us is to be able to spawn a player. Let's take a look at what the player spawner script does. So it's quite simple. This player joined fallback It's going to be called on the server only, and it's going to be responsible for spawning the player. So what I added here is just a prefab pointing, a network object prefab, which we're going to drag and drop the desired prefab. Of course, you could use different ways to select prefabs, or you could instantiate this later using an RPC that we're going to, for example, demonstrate on the weapon inventory initialization. But this example here instantiates a player prefab right when he connects to the server, and this is what we do. We create a position for the player based on his player index, which is a parameter here, and this is what we do. We spawn from the Fusion runner, and the last parameter is the interesting one here, because if you see from the tooltip here, it lets you define who's gonna have input authority for this character. This is gonna let it do client-side prediction, but just gonna be sending input for this player, for this object, to the server, and the server is gonna actually perform the server authoritative move. So let's take a look at what this prefab is. So the player prefab, the player prefab here. So the player prefab is, as expected, a network object, and it has a few important scripts on it. So the most important one for here is our internal character controller. Everything is default here, didn't change anything. I think I clicked on air control for jumps here, but this is not really important. But of course, you can use your own character controller if you understand the principles. You have to move this guy through our network fixed update. I'm gonna show that, but this is a good basis for you to start with anyway. And then we have three important scripts here. So I decided to make one just for movement. I called it player movement behavior. I'm gonna start with it. Then later on, we're gonna check the player weapon script, which is the one that does lag compensated raycasts. And then we have also the bonus thing, which is the player inventory thing. The color tag is a common script we use to let you identify objects that are actually from the server and from the client. And so we normally use this. I'm going to demonstrate when we actually run it here. So let's click play very quickly here, and I'm going to make sure to start both a server and a client. So we're controlling the camera here and this guy, but you see that you see in green you see where the object is on the server, and in red you see what you're actually seeing here, which is the interpolated delayed proxy of this object in this case, because these objects are just moving targets controlled by the server. So I just wanted to show. So the color tag I also use on the player prefab, but it's also on these moving target objects here that we're going to show it. And so before we get to the player movement, let's understand how input works on Fusion when you're using the full client prediction loop that you can. So we'll start by showing that you can define this instruct to represent what is a player input. You just have to derive it from iNetwork input, and then you add data to it here. So these are just like constants to mark which bits we're going to use for each one of these buttons. But technically, the only data that we're sending as input is 32-bit int to represent buttons that we have pressed right now. So it's the current state of the, let's say, controller. We're trying to move to any direction, and we're using a specialized number that we provide called angle, because it's a very high accuracy quantized number that you can use for these, and this is going to be to represent the camera movement. And that's it. I mean, helper script to simplify you checking if the button, if a certain button based on this constants is pressed or not by doing the bitwise comparison, the bitwise end here. Then this is just the struct for the input. How do you use it? So to use this, if we go back to our runner in our prefabs here, we're hooking up to the runner these networked events, which is one way of hooking up this callback. And we're using this networked events script to set it to call this method called onInput on this script called input polar, which is also added here. So let's take a look at the input polar source code so you see what it does. So onInput, receives network runner, and the network input struct for you to fill data into. What we do here is we create a new copy of the struct we just showed, the one that has the buttons and the yaw and pitch, and we fill in the data based on the current status, or this is, for example, on a PC demo here, what is the status of this button press? And we're also sending the camera yaw, accumulated camera yaw and pitch, but I'm going to show that later because there is a special setup for this. But it's just important to know that here you're getting the tuple from yaw and pitch that you get from the camera, and then that you set the data into the provided input struct. And that's it for the input poller. So this is going to be called on the clients for the network on this script here, and this is going to be used to grab input for this player that's controlled by this game client. Then any script that runs on an object where input authority belongs to this player is going to be able to grab, to pull this input and use it, for example, for movement or for weapons, and that's what we're going to show next. So remember that our spawner creates a copy of the player prefab, which has all these scripts here, one for movements, one for weapon, one for inventory, and so on. So let's see what the movement script does. Let's click here. So the movement script, it's going to have a copy of the current yaw and pitch of the character, because we're networking this. So and then the character controller only cares about the movement, we're gonna do this by hand here because the FPS is it requires this kind of special setup. So it needs a reference to its own character controller to be able to move it, and as soon as it gets spawned, I'm gonna set up the camera, which is I'm gonna set up the camera to know this is the local player, if this is the local player, so we can follow this character like first person camera. You could do this differently. You could spawn the camera as part of the player prefab. That's also a common setup on FPS games, but this is one example of how to do it. But the important part here is how the input is pulled. So this method, fixed update network, is the taker, is the fixed update from the network simulation rate that you set on Fusion's configuration file, and this is important because this is going to be called in these objects that have input authority assigned to a specific player. It's going to be called only on the server and on the game client that has input authority for it. So then what we're doing here is we're reading the input data that is that struct that we set that has the buttons, and we're checking which buttons are pressed. So we define what's the direction the player is trying to move towards, and then we're going to use that to use the simple, let's say, prototyping based move from the character controller. Of course, the character controller itself deserves a full video on it just for you to understand a bit better how to use the raw movement query, but we have shared the sources for the move method and the raw steering example methods that are the ones that you normally want to modify to, but you might want to reuse the internal movement query. But as I said, you can use actually any character controller that you like, as long as you drive the movement of the character controller from here and you do network the variables that matter, like the character controller cached velocity, and if you're modifying the position of the object on the transform directly, you have to network that as well. You could either use a network transform that we have that also allows for local client-side prediction, but perhaps you want to do that manually. That's what we do for this one here. So this one synchronizes both the transform and its own velocity. So it's a good start for you to use, but of course you can augment it. And see that we're overhauling the rotation of the character itself with the yaw and pitch, so we ignore the rotation that's then synchronized by the character controller, and we overhaul it both on the server and on client-side prediction by the one that we get from camera input, because that's how you do on an FPS. So that's the basic. That's it. This script here is called both on the server and on the client, both for predicting the new ticks and also for when rolling back and resimulating for reconciliation. So you don't have to worry about anything else. You just write your code here, modifying directly the Unity transforms. That's what this CC mono behavior does. It modifies the transforms directly. We're going to see on another script that that's exactly what we're doing, for example, with the moving targets. That's all you need to do. Client-side prediction is done here. Then when you receive data from the server, data is fixed and snapped, and then the resimulations are called again. Call again this method here so you can advance your character again. So the next, let's say the next important step here is, let's just take a quick look at the FPS camera setup. There is a specific video I also explain how this can be done. So this comes with source code. You can see it's exactly the same sources that I have on the other video, but it's still worth mentioning. So the FPS camera it normally requires a special way of doing things in terms of the order in which you do. So the first thing you have to do is, remember, so the simulation happens on a fixed rate. It could be 60 Hertz, could be 128, depends on how you're trying to build your game here. It could be a very competitive 128 Hertz game, but let's say it's a 60 Hertz additional FPS. A lot of players are going to have much faster computers that with 144 Hertz monitors. So you want the camera to be super snappy with that. So what you do here is the first thing you do is you accumulate the hardware data from the mouse axis into a local yaw and pitch, which is the same type angle that I said before. So we're just storing what is the movement deltas, from the mouse. And we do this from this callback called before update, which is from this interface here from Fusion, which means this is going to happen on the Unity update, guaranteed to be before anything else Fusion does. So any of the several, the network, snapshot application, the reconciliation, everything. So it's guaranteed that this is going to be the first thing to be called. So we consume the hardware data from the mouse here to accumulate locally. So the second thing that happens is that if we have a new prediction, a new input to be done, this is also going to be called. So notice that this can be called many times to accumulate the individual deltas if you're running very fast monitor. But then eventually you're going to have this called once that sends all the accumulated deltas to be injected as input. If we remember, that's called from here, and we just send that as input to the server and also to be on the local prediction. So when that's done, we also make sure to clean the local accumulated, because we already sent the one that we needed, that we have accumulated before, to the server. And so that's step number 2. Step number 3 actually happens on the character controller itself, which is consuming the yaw and pitch from the input and applying it to the copy that's kept as part of the game state, networked game state on the character controller, let's say the movement controller of the character controller here. And this is what we're doing in that line of code here. We grab from the input. So this happens both on the server, this is server authoritative, but also happens on the local prediction here. Client-side prediction also gets the same input and applies locally, so you can have an immediate feedback on that. Actually, the immediate feedback is both this and the local accumulated delta on the camera itself, which brings us to step number 4, which is last one, which happens after everything. So when render is called for the camera, what you do is you will apply as the yaw and pitch for the camera the current authoritative yaw and pitch of the character, authoritative plus client-side prediction, which is the networked state of the yaw and pitch of the character itself, plus the local accumulated deltas, because these are called more frequently than the actual tick rate of the game simulation, assuming the player has a super nice setup. Then that's what we're going to use as the rotation for the camera. We move the camera to snap also to the character. This could be a more complex setup, placing it with a pad and so on, but the rotation has to be done based on this input, including the local accumulated one. And finally, we also snap the character rotation itself to be this, because you might ask, aren't you already doing this here? Yes, I'm doing this here, But this is just for the server side to make sure tick by tick you have the authoritative version. But on the local copy, I want to overhaul that and actually use the sum of that one, which is what you get from here, plus the local camera delta, because you want the local character to rotate very, very fast with your local camera. And that's what's actually been used here for the yaw of the character. That's it for the player, for the camera. Now let's take a look at how lag compensation works in Fusion. Topic number 3. So lag compensation in Fusion is quite simple to use. I'm saying it is simple to implement it internally, but it is quite simple to use. So requirements are you add a networked object with this script called hitbox manager. You define how long you want your hitbox buffer to be, what is the limit of lag compensation you want to do on the server side, and it's set here to 60, which is 1 second at 60 Hertz, which is the setup we have here. And it lets you choose a few configuration options for the internal broad phase of the lag compensated hitboxes, but this is gonna have a lot more data later on. But for now, it will. The only important thing for you is to decide what kind of accuracy you want to have. So this is super cool. So when you choose tick accurate lag compensation, what means is that when you're seeing something from the perspective of a certain game client, you're seeing an interpolated version of some snapshots you have from the server currently. So you're seeing data a bit in the past. So what you do is you are raycasting against, if it's a hit scan, for example, you're raycasting against what you see, and because what you see, that's what you're trying to shoot. On the server, what happens is that the server is going to record the positions of all these hitboxes on each one of the ticks. And when the server receives is going to execute the simulation corresponding to the tick where your hit scan or your projectile is going to do the delta movement snapshot, raycasts, it will raycast against the data as you are seeing it. And this is only possible because Fusion already gives the server the data tick by tick, telling the server what were the 2 ticks the client was seeing at that moment, what were the interpolation from and to on the world snapshots that the client was that particular plane was seeing, and how long in between these 2 he was actually seeing when he shot that raycast or when that bullet hit something. And because the server knows that, when you use tick accurate mode, what means is that what you saw was an interpolation between 2 snapshots, but the server only has the data about the from and the to tick. So it has to decide against which one of them he's gonna raycast against, and it does based on which one is closest based on the alpha interpolation you were using. If the alpha is below 0.5, it means that when you saw it, what you're seeing were closer to the from tick, so that's the one that's going to be used. If it's more than 0.5, it's going to use the upper tick, the to tick. When you use sub accuracy though, that's quite cool. It will give you exactly the positions when it does the narrow phase checks as you are seeing. So it doesn't matter if, for example, the game is running at 60 Hertz and if your monitor is 144 Hertz and you got a headshot very, very close to the ear, something like that, because in between the ticks, that's what we were seeing. That's exactly how the server is gonna raycast against, because it's gonna actually raycast against the interpolation version between these 2 ticks. This is slightly more expensive. It's not a lot more expensive. We still only keep the data tick by tick. I'm not gonna explain the details on how this is done, but it's just slightly more expensive. But technically what you normally do is, if you're doing a competitive game, you should use sub-tick. If you're doing something like a battle royale, you want to go 100 plus players, normally you use tick to save some CPU on the server side, just because you're going to have a lot more things going on anyway. So, but yeah, try, experiment with these and see what will happen. So this is the main manager for hitbox, for lag compensated raycasts. And to set up things to be lag compensated, we do not use physics for that. So our raycasts embed also raycasts and shape overlaps against physics for you for the static data. So if you hit a wall, we're going to return the wall hit, which just has to be a normal Unity Physics Static Collider, anything like that. So for example, these things, they can have their own colliders, not only for the character controller movement, but also for hit skins to hit the walls and not go through. We embed the call to that, but technically we use our own hitboxes, and for the lag compensated ones. So we do not roll back physics or anything expensive like that. Technically we can do that for physics prediction, which is something that we're not demonstrating here. It's not for an FPS game, it's for other kinds of games. But that's not what we use for lag compensation. So lag compensation, you actually use the hitbox manager and you set whatever your objects are. It could be an animated character, it could be like moving targets like this example here. Each networked object that has lag compensated hitboxes must have this script called hitbox root. Once. Put it here at the root of the game object. Then if you can have as many children as you want, and any of them can have this guy, a hitbox. And then you, for now, we are offering box and sphere. You set up it here. You can see so this yellow outline here is for the type. Let's show a box example here, just to demonstrate what you can do here. So if we select the box here, this would be the hitbox. This guy, you can make, for example, arms and everything, animation within an animation setup using. I'm gonna keep it sphere here. That's how it was set up before. So you see that this is on a child game object here. So you could have as many as you want here. They will all be automatically registered. That's it. That's it for the setup. And but as a demonstration, these targets are not standing still; they're moving. So this guy is a networked object that has a network transform that's going to be interpolating based on snapshots. So clients only see the proxies of these guys. You see data in the past, so these are not predicted like normally an FPS game does. You only predict your local character. And the moving target script is quite simple. It just moves the character right and left, and snaps to a certain max, and switches direction. That's all it does. But this is enough for the lag compensation system to be required to actually do its job and record the different positions where these things were over the ticks. And that's it. I mean, you showing things here, you just move them normally, and the lag compensation system is going to do it itself. Then, to perform lag compensated raycasts, we're gonna go back to our character player prefab, and we're gonna go to our weapon script. So our weapon script is a networked object that has a cooldown because it demonstrates something else as well. It demonstrates as well the sub-authoritative gun recoil that modifies directly the pitch of the camera that's going to be used to render the camera. And it's cool because this happens on client-side prediction, but it also happens on the server. So it's a sub-authoritative, so it's a lot more. Of course, this is not bulletproof because we know how aimbots work, but at least it is server authoritative, so it's the very good start for this whole thing. And it's the right start. But let's go for lag compensated raycast. So that's it here. It's just this line here. So you just acquire a reference to your your hitbox manager that's on the scene. It's a single one per scene here, and all you have to do is you call raycast. You pass the ray data, which is from direction and size. I'm doing a single hit scan here. Of course, you could use this with a projectile that moves in, let's say, 20 meters per tick. But this is a single hit scan, could be longer here. And the only interesting thing here is that you have to pass who's the player who's doing it. So this is passed here because this weapon script is attached to the character, the player prefab. So remember that we set the input authority of this guy to be a player. So he can receive this from the network object instance, who's the input authority for myself, and that's the parameter you pass here. That's all you need because this tells the server when this is called on the server how much compensation has to do. And that's it. And if you chose it to be sub-tick accuracy, that's done. You receive, so this is a raycast that gives you the closest hit. So you're gonna receive back either a hitbox hit or a physics hit, which means you hit the environment. I'm just bothered here with the case where I hit something from the lag compensated hitboxes. I'm showing some debug data here, which is what was the point I hit, what was the position of the object when I hit it, and most importantly, what was the tick that I was seeing when that happened. I'm going to include in the log here what is actually the current prediction tick I'm running my character at, and also on the server, but what is the tick that I actually saw that was used by the lag compensated hit scan here to actually watch data. And this is a kind of a nice way to debug, to check if this is working correctly or not. So that's it. That's it for lag compensation. You don't have to do anything else except for one thing. Lag compensation is very sensitive to the timing, to the order in which you do things. So the rule of thumb is this. The first thing you do is you move everything. So if you have a character controller movement, and that guy has, of course, lag compensated stuff in itself because it target for hit scans and raycasts, other bullets or grenades, shape overlaps. You must move that, or moving targets that you have, like the demos I have here. You have to guarantee that they run before the hitbox manager. And then this guy, which is the raycast itself, has to happen after the hitbox manager does its job. So this is, you have to use this timing. So how can you enforce that? We do not use Unity's script order at all because that has nothing to do with network, that's local execution. So here's what you have to do. We have this attributes for this. So this is the hit scan one, so this is the raycast one, so it has to happen after, so order after hitbox manager. Just add this, done. Every time fixed update network is called here, it's guaranteed to be called after hitbox manager does its job, did its job. And then for everything that moves, it's the opposite. So if you see here again, so this is the moving target thing, you see that it is actually executing before hitbox manager. And I also marked it here to only execute on the server because everybody's only seeing this guy as a proxy. So this is we don't have to waste the CPU on the client side. So there's a lot of interesting controls you can do with these attributes, or just doing ifs as well. But this is better because it's cut even before the callback is called. If you see here, I think I set it up here as well. I did. So the movement of the character is also happening before the hitbox manager positions it. That's it for lag compensation. Raycasts. There are a few other options that I'll still add to these things. So for instance, we're lacking here a layer mask option, and I didn't expose the shape overlaps yet, but they're gonna come probably next week. It's most of it is done internally. It's just this quality of life, convenience things, and of course, give us feedback on what you would like to have on this, and depending on what is being asked for. And okay, let's move on to the last thing, which was a request by a customer. So I'm also demonstrating here how you can do inventory keeping, very, very simple here. So let's say you want to have you want to keep the weapons the character has at disposal, and also the one that he's currently has selected, and you want to have something like a select weapon bind thing at the beginning of the game, like you do in Counter-Strike. So this is what is demonstrated here. So for player inventory here, I mean a static array of bytes to represent the, let's say you have up to 255 different weapons in your game. So here you're saying which weapon you have in each one of your up to 3 slots here. So this, so we're gonna add dynamic collections, network dynamic collections to the API later. But for now, we only have the static array option. You can set it as big as you want, but in this case here, I want to have up to 3 weapon slots, and I make it networked. And this is the special type. It's a static array of bytes. You set it as a getter only here for the weaver to do the job here. And I also have what is the currently selected weapon, but this is not being demonstrated. Mostly the one that's being demonstrated is this guy here. Well, how is this? How is it that this is fulfilled at the beginning of the game, but it's still server authoritative? So the way it's done is like this. So say you connect to the game and your character is spawned on the server. So when that data gets to the client also spawns your character, the copy of your character, for which you have input authority for. So then this is also called on the client, and then I check, hey, is this an object that I have control of? This machine, do I have control of the input of this guy? I do not have state authority, that's the server, but I have input authority. So I can then do this, which is, hey, these are my weapons. So of course you do not have to do this from spawn. You could do this when the player playing, selecting stuff and then doing, but I'm demonstrating an RPC here. So first cool thing, RPCs in Fusion are not using reflection, not using any fancy invoke. By fancy I mean slow invoke. It's just direct call here, does its job internally and sets data to be sent. So I'm gonna show how the method looks like. So we're saying, hey, the weapons indexes I want are 2, 5, and 42, whatever it was that the user selected. So I'm sending this as an RPC, and notice that this RPC is enforced. It can only be called from the object that has input authority over from the client that has input authority over it, and the target it will be the server, the state authority. It will not go through other clients and so on. So this is mandatorily on here by the code, and it's just a method that you flag as RPC. And then see what I'm doing here, because the receiver, the target is only the server here, and this is enforced by the APIs. What I do is this is a syntax quirk that's going to be fixed later, but I grab a copy of that array that I set here, the networked array. Remember, this is happening on the server. Then I set the chosen weapon slots to be that, and that's it. This is going to run on the server only. This is not running on the client. And that sets the state of these selected weapons. And to demonstrate that that's actually working, I'm gonna this is of course super slow. I mean, we were missing a 2-string. I'm not sure if this version already has a 2-string of these arrays, but I just did a quick and dirty and slow demonstration here to show that this actually worked. So this is a non-networked property, non-networked field that I'm filling in with whatever I have on the array right now from the Unity update. So let's see what happens when we run this. So I'm gonna run again both server and client here. Super easy to prototype and test. And we're gonna see here what the server copy of the player prefab has and what the client copy of the client prefab has. First, if we check the logs here, we have the callback that the player was spawned here, and then you have the log that the client is sending the selection to the server, and then the log that the server received the selection and set the inventory. So let's see what's on the server side of the inventory. You see that the string copy of the thing here shows 2542 as expected, and the same happens on the client side. So you have here 2542. That's it. It's a super simple demonstration of RPCs and networked array, but it's a good solution for getting more complex things done in terms of of inventory. Remember, Fusion offers a lot of different ways of doing state sync, including I mean two ways of synchronizing data, which are delta snapshots, full world snapshots, delted, and eventual consistency. And when using eventual consistency, you will be able to do interest management. So don't worry about people seeing stuff that they should not see. You will be able to set that you should not even have updates of a certain object if the object is not in your vicinity, or if the object is behind something. You'll be able to set that from the server side. That's the internals are all done. We're just deciding on how to export kind of API. But yeah, I'm not gonna cover the configuration object configuration settings on this video yet, because it was really focused on these specifics to FPS. But feel free to ask stuff on this. And the last thing that I'm not gonna demonstrate yet, but I just wanted to mention is, if you ask about animation, I mean, if you want these lag compensated hitboxes to be part of an animated character, of course you want that. It's a competitive FPS. So how do you do that? So you add hitboxes exactly to the bones of the object. That's it. That's exactly what you're gonna do. You're gonna add the hitboxes to the bones, and technically from the lag compensation part, that is again. But for that to really work, you have to have tick accurate, or even sub tick, which is given, um, accurate animation sync. And that cannot be done with Mechanim, because Mechanim cannot does not allow us to set the timing directly. That fortunately is possible to be done with playables, and I already have the demo for that. We're just waiting to have some animated characters that we can actually share that have the kind of animation to do the blend trees that I want to demonstrate, and then we're gonna share that. But if you're super curious about it, ask on Discord. I can explain what you have to do and show the things. The fact is, it's with playables, it's very easy to have the animation match exactly. I've shared some animated GIFs of this before, and yeah, you have foot positioning, or the hands, and the whole thing, both idling, running, moving, fully synchronized, tick accurately between clients and servers. And because of that, when you use hitboxes as part of the character bones, they're gonna be inherently in sync, and then the lag compensation works flawlessly as designed without any modification they have to do. But just to mention that, so the animation setup sample is gonna be added to this sample later on. It's just not part of it right now because I cannot share the animations I used on the original sample on the first time I coded this, but it will be possible to do soon. So hope you guys enjoyed what I'm showing here right now, and yeah, see you next time.